Welcome to our tutorial about noise gates. This is the fourth type of dynamic effect that we'll be learning about in this course. As you may remember from our previous video, expanders reduce the output level in relation to the input levels for signals below a set threshold. This is useful for enhancing dynamic range. In fact, it's the opposite of compression, which squashes dynamic range. This might seem kind of confusing, but basically expanders are ideal for reducing the noise in quiet passages. Let's say if you're recording instruments that are acoustic and aren't mic'd close up. A noise gate as a type of expander is just more crude. Instead of adjusting the volume by a ratio, it reduces the signal to zero when it drops below a certain level. No sound, noise or otherwise, is allowed to cross the gate unless it's louder than the threshold in decibels that you set. Then the gate opens at this point, letting through signal and noise, but the idea is that the noise is less troublesome when it's covered up by some other sound, and that's definitely true. In addition to eliminating background noise when there's no signal, noise gates can help you clean up drum tracks by removing leakage between the beats. It can shorten the decay time of drums to give a tighter sound too. And if you're recording a noisy amp, you can use a gate to cut out the buzz and hiss between phrases. Just be careful not to set your noise gate threshold too high, or you'll be cutting out some of the richness of your music. You'll be able to hear where this point is when you listen and test. For example, a spoken vocal will sound disembodied, and a low-lying instrument won't have much body at all. Generally, you need your frequencies above 45 Hz, so I wouldn't even think about applying a noise gate above that level. Let's take a look at a gate plugin in Cubase. We're going to check out how the standard controls work and then apply it to a track. Again, the primary controls on a noise gate are similar across plugins, so once you understand the logic behind one, you'll be able to figure out other plugins too. The threshold, that's when the gate kicks in. Signal levels above the threshold open the gate. Anything below closes it. Anything below that threshold is gone. The attack is measured from 0.1 to 1,000 milliseconds. It sets the time it takes for the gate to open after being triggered. Next is the hold control. This determines how long the gate stays open after the signal drops below the threshold level. Hold is measured in 0 to 2,000 milliseconds. A wider range that can accommodate quiet phrase endings and reverb tails. If you've got the sidechain option activated, you can activate the monitor button too to see the filtered signal. It appears here in these meters. With the sidechain button active, you've got more options for tailoring the gate. There's some control names here that you should recognize by now: center, Q factor, etc. Yes, indeed, the input signal can be shaped using EQ parameters. So these filters are available to you when the sidechain option is active. LP stands for low pass, BP stands for band pass, and HP stands for high pass. So the low pass lets through the lows, the band pass lets through frequencies of a certain band, and the high pass lets through the highs. You use the center and Q factor controls to set the center frequency of the filter and the bandwidth of the filter. Now let's listen to a portion of this track and see what we can do to it using a gate. Let me select a silent or quieter portion. The stats tell me that my peak amplitude is about -60 decibels, so that's pretty quiet. Let me check another spot just to see how it measures up there. Here the peak amplitude is quite a bit higher. I must have been breathing or something like this. Maybe I have some noise on the microphone. I'm just selecting a section with recorded input so I can check the peak amplitude there. About -9. That's a pretty hot part of this vocal. Let's take a look for a more subdued section of the vocal. I'm selecting an area where the waveform is visually quite a bit smaller. Let's take a statistical measurement. We've got my peak amplitude at about -14. My levels are pretty good. I might even be able to set the noise gate a little higher than I thought I could. Let's exit the Statistics dialog window and set up the noise gate now. First, we're going to listen without the gate. There was an old lady who swallowed a fly. Let me load a preset, Clean Lead Vox. In this preset, look how high the threshold is. Anything below -26.3 is going to get cut right out. There was an old lady who swallowed a fly. I don't know why she swallowed a fly. Perhaps she'll die. There was an old lady who swallowed a spider that wriggled and wriggled and jiggled inside her. Did you hear how the sound went in and out a little bit? That happened because any time I fell below the threshold, the gate kicked in. You also heard all that background noise. You can't count on a gate only to cut out background noise. This threshold level is actually pretty high. If I do use a gate, I rarely set the threshold much higher than the level of the background noise of the studio where I'm doing the recording. Let's lower the threshold and listen. Who swallowed a fly. I don't know why she swallowed a fly. Perhaps she'll die. There was an old lady. So with the lower threshold, my vocal doesn't cut in and out, but that background noise is still way too hot. Do your work to get the studio quiet before you start. And this concludes our overview of working with a noise gate. In my next video, I'll show you how to normalize your work. Like the noise gate, normalization is another dynamics-based effect.